these are called the nanoparticles, also known as the quantum dots, which has a dimension about 1 billionth of a meter called the nanometer, right? So these particles are definitely cannot be visible by optical microscope, but we use some sort of electronic microscope, which are called the transmission electron microscopy, in order to view these sort of particles. What you see in this vial is actually a solvent that are having these sort of nanoparticles, which are about 5 to 10 nanometers in diameters. They are sort of like spheres that you are seeing in here. Okay, so when we try to understand the size of the particles, it's always good to compare the size of the things with known measures, right? So the thing is, when you compare the size of these particles with a soccer ball, for example, what is it to a soccer ball is actually the same to an Earth. So basically what you do is actually, if you magnify everything 60 million times, okay, if you have your spheres like 60 million times larger, then your soccer ball would be the size of the Earth, right? So we all played with marbles when we were kids. I'm no longer sure whether these kids still play with these sort of marbles, but the thing is, when you change the size of these marbles, nothing changed, right? In macro world, we are limited by the Newtonian mechanics, and when you change the size of the objects, actually, you don't expect to have the change in their optical or electrical properties, even their mechanical properties. But the things are quite different in the nano world. What happens is that when you change the size of these objects, actually, they behave differently under optical exciting. So therefore, the thing is, by making use of these particles, actually, it's easy to engineer the properties of these particles. So therefore, whatever the reason is, you can change the quality of the light that you generate, right? This is a huge thing. So that's the reason, actually, we call them artificial atoms or artificial molecules rather than normal crystal structures, because by changing the dimensions and the crystal composition of these materials, you can target different optical spectrum that you wish. So you are no longer limited by the elements in the periodical table, but thanks to the nanotechnology, you can change the properties of the materials of the interest. And the thing is, actually, you are no longer in the Newtonian mechanics regime, but now as the size shrinks in size, and when you are in the nanoscale regime, then you are with the quantum mechanics. You are under the influence of the quantum mechanics, and the equations, therefore, is totally different. So how does it affect our daily life? So basically, the thing is, these particles that are emitting, in principle, can be used for many applications in biotechnology as well as in the optics and electronics too. Because the thing is, at the end of the day, what you're creating is light. And in order to, for example, diagnose a disease, for example, you send out some biomolecules to your body. And in order to trace these molecules, these quantum dots that are emitting materials are good way to visualize these particles by optical excitation. The thing is, in this place too, we are making use of these materials, and we will see how, actually. In our daily life, we are making use of these displays heavily. So from our mobile phones to laptop screens or the televisions that we use at our home, we are always using these displays, and they are commonly known as the liquid crystal displays too. So the liquid crystal display, if you look into what is inside the liquid crystal display, it actually starts with a backlight unit on the back plane. So this backlight unit provides the light that we see on the screen. So after these backlight plane, there are reflector, optical sheets, and there is the so-called liquid crystal layer that we manipulate the position of the liquid crystals by the electric field, by controlling the electric field, and then we let the light out or not. And there's also a color filter at the end that would select whether we have the red light, green light, or blue light on the screen. And by making a good composition of these colors, actually, you can achieve any color you have on the screen, right? However, the thing is, actually, this light that you are using on the back plane is made up of a blue LED together with a color-converting phosphor layer, okay? So you have a fixed emission spectrum, and then after the filters, you get the red, green, and the blue components. However, what if you have very pure emitters? Very pure emitters means that you have very niche colors, you have a very niche green color that doesn't interact with the blue. You have a very pure red color that would resemble the quality of the strawberry in the nature, for example. So therefore, using these particles actually, it is possible. And effectively, you can achieve from 60 million different colors in a conventional display, you can enhance it to 1 billion different colors. You can tune the shades of the color spectrum by making use of the very pure emitters. And this is thanks to the materials that we use as the quantum dots. And these particles are now readily being available in the market, and they're expected to reach like tens of billion US dollars as a revenue in the technology. So the thing is, it would be possible to mimic the real colors in the nature in our displays too by making use of this technology. And according to the market forecasts, it is expected that we would be able to have over 50% of the monitors and the computer screens that we use in everyday life will be made up of these materials in the near future. So the future is not that far regarding these. So what we do, actually we are heavily using these materials in our lab for both the existing liquid crystal display technology as well as the next generation organic LED displays. We are working on the synthesis, design, and the application of these materials in our lab. So the thing is, the challenge in this technology is, okay, we have very good emitting particles. However, how about the environmental aspects? So what we focus on is to create particles that are free from heavy metal ions, like cadmium, for example. So the cadmium is, as you know, is prohibited, so you cannot use them wisely in the domestic applications that you use in your homes. So therefore, actually, our main focus in the lab is actually providing high-quality materials which are cadmium-free, basically, so that would end up with niche applications in the display technology and also for the lighting applications too. We are always talking about the displays, but the thing is, about 20% of the light that are being used in everyday life, we use the 20% of the electricity just for lighting application itself. So it means that if we have efficient light sources, that would mean that we would have less power plants and everything will follow accordingly. And the recent news is that last month we attended a QD forum in San Diego, and our studies were one of the milestones in the technology that our work was cited by Samsung Electronics in their presentation, that we are one of the leading key players in that technology too. So what is next? So the thing is, now we have the rigid screens, right? We cannot bend them, we cannot roll them, we cannot have flexible screens yet. And expect from the lab demonstrations, definitely. So the thing is, the LCDs will be taken over by the organic light emitting diode technology. What is an organic light emitting diode? Actually, by using organic materials that are deposited on top of each other, it would be possible to have paper-thin solutions which would be made flexible, because you are not using rigid components as we use in our LCD technology, for example. So therefore, it would be possible to have, for example, like a newspaper, think about electronic newspapers that can be rollable, and then we can put them in our pocket, basically. So there are early demonstrations already. So actually, these are not going to be taking long to go into the market. There are very niche demonstrations already by the different companies. And for example, this is a Chinese company, Boe, and also we have the demonstrations of flexible light-emitting diodes as well, made up of these organic layers. So the thing is, it all definitely starts with a dream, and actually, there's nothing like a dream to create the future. Thank you so much.